this lecture on integration. In the last lecture, I showed you how to calculate the area under the curve between 2 points A and B using Raymond's summation. Okay, today we will see how we can find out the integration, that is finding out the area under the curve using the general formula or arriving at the general formula for integration. Now, integration is the reverse of differentiation. Okay, so if we take this into account, let's see how it is. I'll take any equation. Y is equal to x squared. Let's take y equal to x squared. Now, dy, we know that from differentiation that dy by dx is equal to 2x. So, now if we are to integrate 2x, we should get back the value of y. So, if we are differentiating y, dy by dx is 2x. Now, if we integrate 2x, we should get back y, that is x squared. Okay. Now, let's take another one. Y is equal to x squared plus 1. So, here also we will see that dy by dx is equal to 2x because differentiation of 1 we found out was 0. So, now if we are to integrate again 2x, we said here we will get x squared. And here if we integrate 2x, we are going to get x squared. So, where will 1 go? So, let's take another one. Y is equal to x squared plus c, where c is any constant. Again, dy by dx is equal to 2x. So, again if we were to integrate 2x, we would get back x squared and not c. So, basically, when we are integrating any function, we do not know what the original expression was. So, in this case, after integrating any expression, we add a constant of integration. Okay. So, when we want to integrate we do not know that the original function had a constant or not. Therefore, we write y equal to x squared plus c, where c is called the constant of integration. Okay. Y is equal to x squared plus c is called the integral of 2x, and we write this as integral of 2x dx is equal to x squared plus c. Okay. So, basically, this is the integration sign. This is the integration sign. We integrate 2x. Okay. This is called integration of 2x with respect to x. And the answer is x squared plus c. So, whenever we have y equal to x squared plus c, this was the original expression. and we integrated, we got 2x. So when we are integrating 2x with respect to x, we get back the original expression x squared plus c. That is why integration is called, basically integration is the reverse of differentiation. So okay, so let's see how we can come to the formula for, general formula for integration. We said that when y is equal to x squared plus c, dy by dx is equal to 2x, right? So we can write this like this: dy is equal to 2x dx. Okay. Now, if we can integrate this and if we can integrate this, it's the same thing. So, integration of dy is basically is y. Now, integration of 2x dx gives us x squared. So, let's take this expression. How do we get this expression 2x to be converted into x2? So, here x, the power is 1. Here the power is 2. So, basically it means we increase. Basically, if this is x and this is x squared, so basically we are increasing the power by 1. Now, if we increase this power by 1, it will become 1 plus 1, 2. But there is a 2 here. So, we have, if we divide this by the same power, this 2 and 2 will get cancelled off and we will get x squared. So, if we divide this expression by the same power plus 1, we will get back the original expression and we add the constant of integration, which is c, and this is basically what integration of any function y with respect to dx will come to. Now let's come to the formula for integration. How do we come to the formula for integration? Let's take an expression y equal to x squared plus c. We know that dy by dx is equal to 2x. So, if we integrate both the sides, then integration of dy will be integration of 2x dx. Okay. Now, integration of dy is nothing but y. So, we got back y. Now, we have to bring 2x into x squared. How can we do that? Here, x has a power 1. So, if we increase the power by 1, it becomes 2. So, we increase the power plus 1. Okay. And since 2 is there, if this becomes 2 and we divide it by 2, then this 2 and this 2 will cancel off. So basically what we are doing is we are dividing this one by power plus 1 and then we add the constant of integration to get to the final integration formula. So we can write the formula like this. Formula for integration. Okay, so if y is equal to ax to the power n, therefore integration of y with respect to dx is the same as integration of ax to the power n. Now the power is n, so basically a is a constant, so nothing happens to a. We are increasing the power by 1 and dividing by the same power, that means n plus 1, and then we add the constant of integration, which is c. So this is the general formula for here. This symbol here is called symbol for integration. Okay. Let's take some examples to make things clear. So let's take integration of 3x squared dx. So here 3 will remain as it is. We have to increase 2 by 1. So we are increasing 2 by 1 and we again divide by n plus 1, that is 2 plus 1. And then we add the constant of integration, that is c. So this is basically 3x cubed upon 3 plus c, which is equal to x cubed plus c. Okay. Let's take another example. integration of 1 upon x squared dx. Okay. So here it will be equal to, we can write x squared as x to the power minus 2, where 2 goes up, it will become minus 2. So this will become x to the power minus 2 dx. Now, after integration, this will be minus 2. We increase the power by 1 and it will be the same one. So this will become x to the power minus 1 upon minus 1 plus c. So instead of x to the power minus 1, we can also write this as, since this is a minus sign, so it's a minus sign, and x can be written as, x to the power minus 1 can be written as 1 by x plus c. Okay, let's take another example 3. Integration of 6 root x dx. Now we can write this as integration of 6, we can take outside the integral sign, and this can be written as x to the power half dx. Again, it's the same thing as before. We apply the formula for integration. 6x to the power half plus 1 upon x to the power, half plus 1, and we add the constant of integration. This is the same as writing 6 to the x to the power 3 by 2. Half plus 1 is 3 by 2, and we divide it by 3 by 2. So this will become 4. So because 2 will go to the top, so 2 into 6 is 12. 12 divided by 3 is 4. This will be x to the power 3 by 2, and we add the constant of integration. Okay. Okay. In this formula for integration, okay, since we are adding one power, so if n is equal to minus 1, what happens when n is equal to minus 1? This n. So if it is x to the power n, where n is equal to minus 1, where x is equal to minus 1. So when n is equal to minus 1, let's say y is equal to x to the power minus 1. What happens when this is the case? So in this case, integration of x to the power minus 1 dx, when we are adding the power of minus 1 and we add plus 1, it becomes 0. So this expression will become x to the power minus 1 plus 1 upon minus 1 plus 1. Minus 1 plus 1 is 0. So this is a division by 0. So in this formula, n cannot be equal to minus 1. There is a separate method for finding out such an expression, which we will come across later. Okay. For the moment, n cannot be equal to minus 1 for this formula. Okay.